Imagine this. You're, right in the middle of your day. Things are going smoothly. Maybe you're streaming something. Video call for work, just browsing. And then, boom, nothing. Your internet just stops. No
Yeah.
websites load up. Connections just time out. Complete digital silence. It sounds traumatic, but for a huge number of people worldwide, that's exactly what happened back on July 14th, 2025. So today, we're doing a deep dive into, well, one of the biggest internet hiccups of the year, the Cloudflare 1.1.1.1 DNS resolver outage. And our mission here is to get past the headlines. We want to unpack not just what went wrong, but the really surprising, kind of sneaky details of how what seems like a tiny internal config mistake spiraled into a global problem for so many. We're really leaning on Cloudflare's own Postmortem report here. It's incredibly detailed, actually, and it gives us this fascinating window into the invisible machinery that keeps our digital lives running. So Cloudflare's 1.1.1.1 service, it's this public DNS resolver. Millions use it, maybe without even knowing it sometimes, to get online. It's like the internet's phone book, turning website names into IP addresses. When it went down, for a massive chunk of users, it literally meant, and this is Cloudflare's own words, basically all internet services are unavailable.
Yes, go on.
Yeah, and it's really hard to overstate the scale we're talking about with Cloudflare. They're not just some company. They're fundamental to how the internet works for countless sites and people. When you're running a network that massive, that complex, I mean, even a seemingly tiny slip-up in configuration, well, it can have these huge, widespread effects.
Okay, let's zero in on that immediate impact then. The outage itself, it started at 21.52 UTC on July 14th, 2025. Lasted 62 minutes, which, if you were affected, probably felt way, way longer.
Oh, absolutely.
And it hit 1.1.1.1 users everywhere globally. Just pulled the rug out.
Right. And to get why this happened, it helps to understand the 1.1.1.1 service a bit. Cloudflare rolled it out in 2018, right? Free service became super popular very fast. They use this routing technique called Anycast. It's actually pretty clever. It lets traffic for one IP address, like 1.1.1.1, get handled by loads of different data centers all over the world.
Which is great for speed and handling lots of traffic.
Exactly. Better capacity, better performance.
Yeah.
But there's a catch. If something goes wrong with how those IP addresses are advertised, how the network tells everyone where to send the traffic, that single configuration problem can suddenly cause a global issue. It affects all those Anycast locations at once.
So when something this big happens, instantly people think, okay, cyber attack.
Right.
Or maybe some kind of, BGP hijack messing with the routes.
That's the natural assumption.
But the Cloudflare report, it said something quite different, almost more mundane, which makes it kind of unnerving. They stated the root cause was, quote, an internal configuration error and not the result of an attack or a BGP hijack. How surprising is that, really? An internal mistake taking down such a critical, supposedly resilient system.
It's always a bit jarring when it's not the external bogeyman, but something internal. What's really revealing here, though, is the timeline. This wasn't like someone flipped the wrong switch and boom, outage. No, this was, well, you called it a ticking time bomb earlier.
A ticking time bomb is exactly right, because the original mistake, the source of all this trouble, it actually happened way back on June 6th, 2025. 17.38 UTC, to be precise. Someone made a configuration change, seemed routine, for a new service, something called the Data Localization Suite, or DLS, and it wasn't even in production yet.
Right, and here's the critical error. That change accidentally bundled in network prefixes. Think of them as the internet's address blocks that belong to the live, heavily used 1.1.1.1 resolver service.
Whoops.
Yeah, big whoops. And because this new DLS service wasn't active, wasn't being used, this incorrect configuration just sat there in the live network for over a month. Like Cloudflare said, since there was no immediate change to the production network, there was no end-user impact. And because there was no impact, no alerts were fired. It just lay dormant. A classic sleeper bug.
How often do these kinds of sleeper errors pop up in huge systems like this? And what makes them so, I guess, uniquely dangerous compared to an error that breaks things immediately?
They're probably more common than anyone running these big systems would like to admit, simply because of all the moving parts and interconnected services. What makes them so dangerous is precisely that they don't cause immediate problems. An obvious mistake breaks something, alarms go off, engineers jump on it.
Right.
A dormant error, though, it can look perfectly fine during reviews, past tests even, because its potential impact isn't visible until something else, often totally unrelated, changes and, pokes it.
Like hitting a specific pothole a month after getting a faulty tire installed, as you said.
Exactly that kind of thing. And if we think about why these configs are so complex, that DLS, the data localization suite, it's all about controlling where data goes for compliance, for regulations. It involves these really specific service topologies, basically, rules saying this service using these IPs can only be reached from these specific regions or data centers. So messing up which IPs are tied to which service topology, even for a non-production service, well, it has big implications.
Which brings us right to the trigger event. Fast forward to July 14th, 2025, 21.48 UTC. Another configuration change gets made, and guess what? It was for the exact same non-production DLS service that had the faulty config from June. This time they were just trying to attach a test location to it.
And that was the moment the dormant error woke up, because those 1.1.1 Guidum resolver IPs were mistakenly tied to this non-production DLS service topology from the June change. This new modification triggered a kind of global refresh of all the network rules associated with that service. And the disastrous result was that the 1.1.1 prefixes, the addresses for the DNS resolver, started getting pulled back, withdrawn from Cloudflare's production data centers all around the world.
So like flipping the switch from open to close on thousands of digital roads leading to 1.1.1.1 all at once.
Pretty much, yeah, a global withdrawal.
And the effect was almost immediate. By 21.52 UTC, just 4 minutes later, DNS traffic heading to 1.1.1.1 just started to plummet. Globally, it basically vanished from the internet map for many users. And just to be clear, because some other reports mention it, there was an unrelated BGP hijack incident around 21.54 UTC involving a different provider. But Cloudflare was very specific. That wasn't the cause of their outage. It just happened to become visible because Cloudflare's own 1.1.1.1 prefixes had already been withdrawn by then.
Right, an important distinction. Bad timing, but separate issues.
Okay, so most users are seeing total internet darkness. But here's where the postmortem gets really interesting. It wasn't quite a total blackout for everyone using Cloudflare's resolver services. What actually managed to stay online and why?
Yeah, this is a fascinating little detail in the midst of the chaos. So the report says that while standard DNS queries, UDP, TCP, and also DNS over TLS or DOT, they saw that massive immediate drop.
Right.
But DNS over HTTPS, DOAH, traffic remained relatively stable. It wasn't completely unaffected, but it held up much, much better.
DOAH. So why? What was different about DNS over HTTPS that made it resilient here?
It mostly comes down to how people connect to it.
Yeah.
See, most DOH users, whether they set it up manually or it's built into their browser like Firefox or Chrome, they don't point directly to the 1.1.11 IP address.
Okay.
They usually point to a domain name, cloudflare-dns.com. And that domain name resolves to a completely different set of IP addresses managed by Cloudflare.
Ah, so those other IP addresses weren't caught up in the bad configuration related to the DLS service and the 1.1.1 prefixes.
Exactly. They weren't part of that specific service topology mix-up. So connections using the domain name largely kept working. The report also mentions some UDP traffic using other IP addresses also stayed up, probably for similar reasons, different addressing, different topology.
That's quite something. It really shows how these underlying technical details, like using a domain versus an IP, can accidentally create pockets of resilience. It's not just academic, it directly impacts whether your internet works or not during an outage like this.
Definitely. A real-world example of protocol differences mattering.
All right, so the network is largely down for 1.1.1.1 users. What happens next? How did Cloudflare figure this out and fix it?
Well, the alarms did eventually start going off. Incident detection was logged at 22.01 UTC, and a formal incident was declared pretty quickly after that. Engineers were on it.
Okay.
And once they pinpointed the problematic configuration change, the one from 21.48 UTC that triggered everything, the fix was conceptually simple. Revert it. They initiated that revert at 22.2 UTC, and almost instantly that started re-advertising the correct BGP prefixes for 1.1.1.1 out to the internet again, like turning those road closed signs back to open.
And that brought things back online.
Partially, yes. It restored traffic levels to about 77% of normal pretty quickly.
77%. Okay, why not 100%? What was holding back that last 23%?
This is where the complexity of their edge network comes in. During the outage, because of that faulty topology change being active, about 23% of their massive fleet of edge servers had basically automatically reconfigured themselves. They'd removed the necessary IP bindings, the links between the 1.1.1.1 service and the IPs on those specific servers.
So even though the main routes were back, a chunk of the servers themselves weren't ready to handle the traffic.
Exactly. And normally, restoring those kinds of configurations across thousands of servers takes multiple hours, according to the report. They use a very careful, progressive rollout for safety. You don't want to break things further while fixing them.
Makes sense.
But given how bad this outage was, they decided to accelerate that rollout process considerably after making sure the fix worked correctly in some test locations first.
So they sped up the final recovery phase.
They did, and by 22.54 UTC, they observed normal traffic levels returning across the board. The incident was officially declared resolved just 1 minute later at 22.55 UTC.
Wow. So from start at 21.52 to fully resolved at 22.55, just over an hour. Given the global scale and the nature of the problem, that's actually a pretty rapid recovery.
It is, yeah. It speaks to their incident response capabilities, even if the initial cause was internal.
Now, looking back, what does this incident tell us about the underlying systems?
Yeah.
Cloudflare's report pointed to some specific technical challenges, didn't it?
It did. It really highlighted an issue with how they managed these service topologies. They mentioned using a combination of a legacy and a strategic system that are synced. And this older legacy system, which apparently involves hard-coding lists of data centers for services, was described as, well, error-prone. Crucially, changes made through this legacy path didn't benefit from their modern deployment methods, like canary testing or progressive rollouts with automatic health checks. A change could just go live globally immediately.
Which sounds exactly like what happened with that June 6th error, right? It got reviewed, sure, but the legacy system allowed it to be deployed globally without any phased rollout that might have caught the issue before it caused harm, even if it sat dormant.
Precisely. It bypassed the modern safety nets. It really underscores that challenge of managing technical debt. When you have old systems interacting with new ones, there are always risks in those seams, especially during transitions.
So what are they doing about it? What were the remediation steps they outlined?
They were quite clear on that. Two main things. First, staging addressing deployments. Basically getting rid of these older ways of managing IP address assignments and service locations. Moving fully to their modern systems that allow for proper staged rollouts with health monitoring at each step so problems can be detected and rolled back before they become global incidents.
Okay, modernizing the deployment process itself.
Right. And second, tied to that, deprecating legacy systems altogether, accelerating the migration away from these riskier, older methods to ensure everything operates under higher standards for, like, documentation, testing, and safe deployment.
It sounds like a familiar story in big tech, really. That constant tension between keeping things running, introducing new features, and phasing out older systems that might carry hidden risks.
It absolutely is.
Yeah.
It's a balancing act, and sometimes, as we saw here, the balance can tip unexpectedly.
So wrapping this up, this deep dive really peeled back the layers on a complex event. We saw this interplay between a hidden, dormant configuration error from weeks prior, a seemingly routine change that acted as the trigger, and the intricate, sometimes fragile mechanics of global internet routing that turned that small error into a major disruption.
And Cloudflare, to their credit, provided that detailed explanation, apologized publicly for the impact, and, as we discussed, committed to those specific improvements to make their systems more stable.
So for you listening, what does this all reveal about the internet you use constantly every single day? I think it shows us that incredible dance of routing protocols, honestly, the surprising power of one single line of misconfiguration in the right or wrong place, and just the constant ongoing evolution needed to keep these massive planet-spanning systems running, reliable, and secure. It's a powerful reminder that even the most robust-seeming infrastructure can have these invisible weak spots, especially in that complex zone where human processes, legacy code, and sleeper errors meet. So maybe next time you open your browser, just take a second to consider all those silent layers. The robust systems, yes, but also the potentially fragile ones making it all work. And it leaves us with a thought, doesn't it? What other dormant errors might be lurking out there in the vast machinery of the internet? And how do we collectively keep designing and building systems that are truly resilient, anticipating not just the obvious threats, but these hidden tripwires too, to ensure our digital world stays connected?